That was loud. Okay, so solving absolute value inequalities. There's a couple things that we have to talk about before we get started. So if you see a less than or equal to sign, that means it's going to be, girls, a less than problem. It's an and situation. Okay? If it's greater than or equal to, it's great or. So that's kind of like the little things to remember if it's an and or an or situation. Yes? Okay. So just a reminder, we're still doing all the same steps we did yesterday. Your first equation, you copy down exact without the absolute value bars. Okay? That's not 11, those are the bars. Okay? Your second equation, you do the, oh my gosh, what was I saying? So without the absolute value bars, you do the opposite inequality and negative after. So I mean after as in like after that opposite inequality. So remember the first part always stays the same. So just a reminder, the absolute value of any number is always equal to a positive, right? Then we learned that yesterday. The absolute value of any number is always equal to positive. And positive numbers are always greater than negative numbers. Right? Aren't positive numbers always equal to greater than goodness. Positive numbers always greater than negative numbers? Yes. So if you see a problem like that has a negative after your inequality, then you know that your answer should be all real numbers. Because absolute values are always going to be greater than a negative. Now, positive numbers are never less than negative. So if you ever see an absolute value is less than -5 or negative anything, what do you think your answer would be? No solution. Okay, so knowing that, let's get started. So we have this. It says solve the following graph. So all the steps we learned yesterday we're still doing. So our first step was to make sure our absolute value is alone. Is ours alone on the left side of the inequality? Is it alone over there? No. What does it have with it? A -4. That's inside. The -3 is inside. What's inside is what we want alone. It's outside. Ooh. Okay. Do you see how I have that -4 on this side with my absolute value? I have to get rid of that. So how do I get rid of that? +4 to both sides. So I get absolute value of 1/2 x minus 3 is less than 6. Now, is what's inside my absolute value bars alone? Yes. So what do we do after we get our absolute value alone? Who remembers step 2? We need to write our 2 equations. Okay, so my first one, remember we write it exact. 1/2 x minus 3 is less than 6. And then we wrote just a second ago that our second one is 1/2 x minus 3, but it says opposite inequality. Well, this is less than. What's the opposite of less than? Greater than, and then negative after. So this should become -6. Okay, so that's the difference here. Okay, the only other difference is if, same as before, if we multiply or divide by a negative, what do we do to our symbol? We flip it. Okay, but other than that, we're solving these exactly like we did yesterday. Okay, so I'm going to draw my 2 lines. Now the other difference is I don't know if this is and or. How do I find out? What did we say? So this is, look at our symbol, our original symbol. So look up here. What symbol is that? Less than. So it's an and situation because it's less than. Did y'all remember that? We wrote that at the top. Okay. So we know that this is this and this. So I know when I graph this, my solution is where? Where it's double shaded between the two, right? Okay. So knowing that, let's solve. How do I solve this? Add 3 to both sides. And I get 1/2 x is less than 9. Now, what does 1/2 mean? 0.5. Does it also mean divide by 2? Isn't it just 1 divided by 2? Yeah. Does that 1 change anything? No. So this is divide by 2. How do you cancel divide by 2? So if I multiply both sides by 2, well, what's 1/2 times 2? 1/2 times 2. You're on the other side already. It's 1. Didn't that cancel the 2? Yeah, we want 1x is less than, what's 9 times 2? 18. Okay. As long as you type it in the calculator, because 9 divided by 1/2, you would just make sure you type that in the calculator. Because if you tried to like write it out, you'd have a fraction over a fraction kind of thing. Okay, so here, what do I do? Add 3. And get 1/2 x is greater than -3. So again, multiply both sides by 2. And I get x is greater than -6. Don't forget this is an and situation. So when I come over here to graph it, I have 2 numbers. Which one's smaller? I have positive 18. Okay, what's this telling me? X is less than 18. Less goes this way, and it's not equal to, so it's a parentheses. Everybody okay with that? Okay, then this one tells me x is greater than -6. Greater goes to the right, is not equal to. Okay, so where is my solution here? in parentheses because it doesn't touch. It's where it's double shaded. Okay, so is over here part of my solution? No. Is over here part of my solution? No. Okay. It's where it's double shaded. It's where it overlaps. That was one of y'all's questions on your assessment. So there's your answer. We're done. Any questions on that one? Okay, so let's look at the next one. Okay, is my absolute value alone? Yes. So what do? I'm going to separate first. I'm going to write my two different equations. Now, one thing I need to know first is this and or? It's greater, so it's or. You're exactly right. Okay, so I'm going to rewrite my equation so I get 3 minus x over 5 is greater than or equal to 6. That's my exact without the absolute value bars, right? Now, then it says opposite inequality, so I still have the 3 over x, or 3 minus x over 5. What's opposite than greater than or equal to? Less than or equal to, and negative after. So what does this become? Negative 6. Now we solve. So what do I do here to solve? Sorry, what? Multiply by 5, yes. That cancels. I get 3 minus x is greater than or equal to 30. Now what? Subtract 3 because that's a positive 3. I get negative x is greater than or equal to 27. Now, can I have a negative x? What can I do to get rid of that negative x? You could multiply, or could you divide? Technically, multiplying by -1 would cancel it, or dividing by -1 would cancel it, so it doesn't matter what you do. We usually divide when we get to this step, so I'm just going to do that so we don't confuse anybody, but you are right. Okay, so this cancels, but what did we just do? So I have to flip my symbol. Okay, so now let's do the other side. Same steps, times 5 times 5. 3 minus x is less than or equal to negative 30. Minus 3 minus 3. Negative x is less than or equal to negative 33. The last step, divide by -1. X, I flip my symbol, positive 33. Okay, do you notice how we do all the same steps? It just gives us a different number. Okay, because it's the same thing, it just equals something, or inequality something different. I don't know how to say that. Does not equal, I don't know. Okay, so my two numbers are negative 27 and 33. So here is telling me x is less than or equal to negative 27. That goes to the left. Okay, x is greater than or equal to 33. That goes to the right. And this is an or problem. Is it okay that they don't overlap? Yeah, remember or means anywhere it's shaded. So like all of this is your solution. All of this is also your solution. So it goes from to the left forever is negative infinity to the right forever is infinity. Okay, so remember we read the graphs left to right. So the farthest left it goes is negative infinity. And then it comes to negative 27 and stops. Or it picks back up at 33 and goes to the right forever. And remember, infinities always get parentheses because you can't touch infinity. Any questions with that one? Cool. Let's look at the back. Okay, two of these our special cases. So really, y'all, we're really close to being done with notes. We've done the longest part so far. Where's my packet? So the rest of this is in your packet. Sorry, y'all. Okay. So, always pay attention. Is my inequality alone on one side of the inequality? My absolute value. Oh my goodness. Is my absolute value alone on one side of the inequality? Whew. My brain is stuck on Monday all week this week. So I'm going to rewrite it exact. And then I'm going to rewrite it opposite sign, negative. Now, looking at my symbol from the original, when my inequality was alone, or my absolute value was alone, what's my symbol? Less than, which means and or. And, so I know this is an and problem. Okay? I like to write it a couple times so I don't forget. Okay, so knowing that, what do I do? Huh? What do we want to do first? What's the ugly part of this problem? Yeah, we need a common denominator. The fractions are terrible. Okay, none of the denominators match, so we can't even combine anything. It looks like a mess. So, what is my common denominator here? My LCD, my least common denominator. 8. They can all turn into 8. Okay, so 4 times 2 is 8. So what I do on the bottom, I have to do the top. That's what keeps it equivalent. So I can do that to both equations, or inequalities. 2 times what? 4, so top and bottom, top and bottom. And then that one's already 8, so we're going to leave it alone. So when I multiply that out, I get 6x over 8 minus 20 over 8 is less than or equal to 13 over 8. So I'm going to rewrite it on this side. 6x over 8 minus 20 over 8 is greater than or equal to negative 13 over 8. I don't usually recommend you do both at the same time, but this is multiplying and it's gross and it's the same on both, so let's just get it over with. Okay? Or, yeah, fractions. Okay, now what do I do? What does it mean when they have a common denominator? We can cancel it. How do you cancel division? Multiply. Okay, so technically if you remember, guys, can you just cross out all the denominators? Yeah, but to prove why, when you multiply anything, 8 times this just cancels the division, cancels the division, cancels the division, so it's all gone, and we get 6x minus 20 is less than or equal to 13. Makes life a little easier. So again, denominators all cancel. I get 6x minus 20 is greater than or equal to negative 13. Does that look better? Yeah. So now what do I do? Plus 20 on both sides. And I get 6x is less than or equal to 33. Now what? Divide by 6. And now that gives me a fraction. What can go into 33 and 6? 3. How many times does 3 go into 33? 11. How many times does it go into 6? 2. Okay, so there's our our fraction. Goodness. Okay, now could I have done 33 divided by, not 0.33, 33 divided by 6, and it gives me 5.5. So is that a pretty enough decimal? I don't mind which one you use, if it's a pretty decimal. So now let's do the other one. So same steps, plus 20, plus 20. I get 6x is greater than or equal to 7. Divide by 6, divide by 6. I get x is greater than or equal to 7 over 6. Now, if I type 7 over 6 in my calculator, does that give me a pretty decimal? No. So, do I want a decimal here? No, leave it as a fraction. But, can I tell you the important part about checking? Looking at 11 over 2 and 7 over 6, if you're like me, I can't look at those and be like, oh yeah, 7 over 6 is smaller for sure. I don't know why, but my brain cannot just look at fractions and know which one's smaller. I hated that part in math growing up. Okay, so I like being able to divide it and find out which number's smaller. Well, 1.14 is smaller, or 6, whatever, 1.1, whatever, is smaller. So my 7 over 6 is what goes on the left. And my 11 over 2, or 5.5, is what goes on the right. Because remember, you have to write their smaller number on the left, because that's your less than side. So knowing this, what does this tell me? X is less than or equal to 11 over 2. Okay. Equal to means it goes into a fancy bracket. This tells me X is greater than or equal to 7 over 6. And that's a fancy bracket because it's equal to. Now remember, what kind of problem is this? And, so it's where they overlap. And both of them had brackets. So I have bracket at 7 over 6, comma 11, all the way to 11 over 2 with another bracket. Remember, this is no longer part of our solution. Any questions? Okay, you're going to love the next two because they're super quick. They are our special cases. Okay. Is my my absolute value alone? What do I need to do first before I even look at anything? Subtract 6. So I get the absolute value of 1/3 x plus 7 is less than or equal to negative 1. Anytime you see a negative, stop. You don't have to do any math. Okay, I mean, you have to think about math, but you don't actually have to do it. Okay, so an absolute value always gives me a what? A positive or a negative number? Positive. So I know no matter what, I can plug in any number in the whole wide world, and this is going to give me a positive number, right? A positive number, is a positive number less than or equal to negative 1? A positive number, will a positive number ever be less than a negative number? No, so this is false. It's not true. So what do you think my solution is? Okay, absolute values are always greater than negatives. Okay? Okay, so absolute values are always greater than negatives. Always, always, always. So look at this next one. Is my absolute value alone? Okay, is a positive number greater than a negative number? So it gives me a positive number is greater than negative 5. True or false? True. So what do you think your solution is? All real numbers. Because a positive number will always be greater than a negative number. I would rather have a positive amount of money over a negative amount of money any day because it's bigger. Okay? I don't want to be in debt. Any questions?